idea is already there with you. Okay, I will tell you how. When we actually talk about rectifiers, okay, we basically use it to convert AC to DC. Right? We already use it. Okay? We already know the circuit, how it looks like, how it works, and so on. But then the output that we actually get is not regulated. In simple word, it means that you're not going to get a pure DC. We need a pure DC. When we're basically having a circuit which actually needs to convert an AC to a DC, okay, and we don't need any kind of signal loss, okay, we don't need any kind of fluctuations, okay, we in general we don't want anything like a pulsating DC, okay, we need a constant DC, okay. For that we actually need to use a specialized circuit which is basically called a regulated power supply circuit. So in general, if you're basically going to get AC to DC, you use a transformer. After that, you use some diode system, and then you get a rectification. It might be a full wave rectifier or a half wave rectifier. But after that, you get the output. But the output is never pure DC. For that, we have to use two additional circuits, and this is what we are going to just look into now. Okay. So maybe I can just start with writing for revision. We don't get pure DC, okay, from unregulated power supply, okay, and so we use, so the question is simple, right? Why we use a regulated power supply? Regulated power supply, okay. So if I just write down a note here, regulated power supply has two additional stages, okay, so two additional stages, okay. So maybe I can just draw it, okay, first, and then probably we can discuss it more easily. So it's going to be a long drawing, okay. We have to draw, in total we are going to draw 5 stages, okay. So let me see how fast I can do. So first thing, I will apply an input, and that input will be in the form of an AC signal, okay, and that input will be given out in the form of a using a transformer. And you know, there are mainly two kinds of transformer, a step up transformer and a step down transformer. So if you are having a household power supply, basically you have got 230 volt. So in order to run any device, okay, which is actually nothing but let's say a DC device, you don't need that much of voltage. So usually, okay, in general, in this example at least, we can use a step down transformer. If we actually use a step down transformer, we can actually get a regulated or a DC power. Okay, so basically a 230 volt, if you are using a step down transformer, depending on the factors, you can actually have, let's say, around 15 volt or 10 volt of step down. So when we talk about converting the AC to DC, what we do is we actually use a diode. So these are the diodes, okay, and the diodes, depending on whether they are forward bias or reverse bias, will actually give you the results. Okay. So maybe you can draw the diodes first, okay. If you can't see it, okay, please make sure that when I record it, you see it on a bigger screen, but I think it's not difficult. You already know about this diode circuit, okay. So I'm not going to explain the diode cycle on how the rectification happens. You already know it from a full wave rectifier. So in a full wave rectifier, we're basically having 4 diodes, okay? And you know, half of the, for the first, let's say for the positive cycle, 2 of the diodes will be conducting. For the negative cycle, the other 2 diodes will be conducting, and based on that, we are actually going to get full wave rectification, okay. So maybe this is the diode circuit that we have, okay, and then maybe I can have this. This is the stage which is also there in a normal unregulated power supply, okay. You can have this also possible. So you basically have a capacitor here, okay, and an inductor here. It's an LC circuit. Okay. So an LC circuit is basically also called a filter circuit, because you know that property of capacitor blocking the AC, sorry, blocking the DC and allowing AC, you can actually use this circuit as filter circuit, okay. But after that, whatever circuit we are going to look into is basically nothing but the important part. So it takes some time, but then let's take that time to actually draw this. This regulated power supply circuit is all about drawing it correctly. So here what we have is a transistor. Okay? So we will actually use a transistor here. Pardon me if the diagram is a bit small, but I think you can still understand it. Okay? A clean diagram is far more important. And this is the fourth or the final stage, the fifth stage. Okay, we are going to have a voltage divider here. Okay, so we can actually take voltage divide across equipment. Let me complete this stage first. Here we do have a Zener diode. Okay, so we have this Zener diode here. Let me just complete this. Okay, let me just take it side by side. So we have got the power supply here, and let's say this is an AC signal. Okay, and then what we have is basically a transformer. So you can represent it in this way. Okay, and then you have got the secondary part. So this is the primary part, this is the secondary part, and let's assume it's a step down transformer. Okay, and finally we can actually have output, okay, across the diode. So if you actually basically consider the output across the diode, we can actually get a full wave rectification or a half wave rectification. Okay, here we do have capacitors, so maybe I can mark this as C1, this is C2. Okay, and then we are actually going to use a filter circuit. So this is your inductor. So this is how it is used here. Okay, and this is L. Okay, this is your inductor, and then we do have a transistor, and then this transistor is actually connected with a resistor. Okay, so complete this. This is additional. This is the important part of having a regulated power supply. Transistor not complete without the arrow. Okay, so it is an NPN transistor, as you can see. And at the final stage, what we have is basically nothing but a long resistor. Okay, and this resistor will actually act as a voltage divider. It depends on what kind of voltage or how much voltage you need from that output. You can actually use this voltage divider. So this voltage divider circuit will have these parts. Okay, so maybe this one going to take across whatever part you are going to take for the output. Okay, so this is basically more or less the working circuit for a regulated power supply. Okay, so before we actually just write down some points here, okay, which is not going to be very difficult, let me just try to divide this into different sections. So maybe I will use different color codes for the internet option. So maybe this is the first part. Okay, and then I can consider this second stage. Okay, so in total there will be 5 stages. Okay, this is the second stage. Okay, the third stage is the LC filter. Okay, this is the third stage. Okay, and then the other two stages are basically a number of options of colors, but then separated this way. This is the fourth stage. Okay, and then finally we have got the fifth stage. Okay, so with these I think we can just mark them. Okay, so the first stage is basically the transformer. Okay, the first stage is the transformer. And the second stage, okay, is basically nothing but the rectifier. You can see rectifier. Okay. And the third stage is basically nothing but the filter. Okay, so this is the filter circuit, and I will just write down RC filter. Oh, sorry, LC filter. Right? So this is an LC filter here that we have. Okay, and the fourth one, okay, is basically a transistor regulator. So this is a transistor. You know, this is a transistor here. We have got a transistor here, and this is basically used to regulate the power supply. So this is a transistor regulator. Okay, and then the final one, okay, the final stage is basically a voltage divider. So this is your voltage divider. In exam, just use a pen and draw it. Okay, I won't even tell you to use a pencil to draw it. Okay, since I have the option of drawing it. But then, you know, this is the circuit that you have to draw, and these are the 5 stages that you actually need to draw. Okay, and this is very important. So what happens usually is, I'm not going to write down too many sentences here. I think you'll already get it. That you might actually have a 230 volt, okay, and frequency is 50 hertz power supply. So if you have a 230 volt 50 hertz power supply and you are using a step down transformer, straight away your voltage at this particular end, let's say if the ratio is, let's say 16:9, a number of turns and so on, okay, maybe here you will get a voltage of, let's say 13 volt at this point. And that 13 volt is actually basically allowed to pass through the diode, okay. For one part of the cycle, it will be regulated, okay, so, or sorry, rectified. So you have it here, right? And when we go, probably I can draw the different circuits here. So when we have this, okay, and then this rectifier, okay, maybe I can just take a different table here, it's very easy for you to understand. So we have got the transformer, okay, and then we have got the AC signal from that transformer. So number one, okay, number one means this, okay, I'm just considering these 1, 2 and so on. So at 1 we are actually going to have this, okay. You can explain it, okay. In exam, if I'm asking a descriptive question, you can still explain it, not very difficult, okay. Number 2, what happens at number 2, you are going to get this. So it's a full wave rectifier, okay. And please remember, in this basically the second part, it will convert AC to DC, okay. And this is basically nothing but a pulsating signal, pulsating DC, okay. It's not a constant DC, pulsating DC. That's the second stage, okay. What happens in the third stage? Okay, in the third stage, after it's actually filtered out, that means you are actually removing some AC components, okay, the pulsating part, if you are removing it, you are going to get a signal which is not going to be smooth, okay. This is going to be something like this. So that means it's rectified partially, okay. The constant DC is partially you're getting it, okay. So this filter, okay, this third one, which basically have the filter, okay, it will basically have ripples in it, have ripples. So this is ripples, okay. So these are ripples. So I don't need that. I need a pure regulated DC power supply. So if you go into the fourth part, that means if you are going into the transistor regulator, okay, this regulator will actually going to give you a this, okay. This removes ripples. It will actually remove the ripples. Okay. So you are almost having a good power supply now, okay, DC power supply, which is actually regulated, okay. And then you can actually consider how much voltage you need using the voltage regulator, okay. So if I just consider this 1 plus 2 plus 3, okay, I'm writing down it in short. So during exam, if you draw the diagram correctly, after that you can actually explain it very easily if you remember just these 3 points, some points, okay. So if you take 1 plus 2 plus 3, you are going to get a unregulated supply, unregulated. Okay? And once we use the other component, we can actually use the voltage divider actually to take whatever output we need. Okay, we are going to have an regulated power supply. So 4 plus 5 is added for regulated. Please don't write it down in this way. This is an easy way to write down so that you can remember. Okay, regulated. Okay, and maybe I'll just complete it in this slide only. Okay, note output. Output is taken across. Taken taken across the voltage divider. Okay, so if you consider the voltage divider, that is important to actually take the output, because whatever values you need, 5 volt, 10 volt, you can actually consider the output across this or across this and this. So more voltage across this and this for even more voltage and so on. Okay? So you can actually take the output across. So this is actually all about a regulated power supply. Okay. So what I'd like all of you to understand is try to remember this circuit. Okay.